Dear student, today we are going to start the physical pharmaceutics. There are different units are there. The most important unit is colloidal dispersion. This colloidal dispersion is also called as colloids. This is foremost important in pharmaceutical field. Not only in pharmaceutical field, these colloidal dispersions are most important for in daily life also. For example, in daily life examples, there are so many things are there. There are body creams. These are all some examples of colloidal dispersions where daily we are using. That is body creams. What today morning we have to take breakfast as a bread, milk, ice cream, toothpaste, beer, yogurt. Yogurt is a food produced by the bacterial fermentation of milk. These are all different examples of colloidal dispersions in daily life. Not only this, some other examples are also there. There are different colloidal dispersions like buttermilk or milk. What we are using, that is a shoe polish, jellies, synthetic polymer, fog, mist, even blood cells, RBC. These are all examples of colloidal dispersions. That means these colloidal dispersions is not only in daily life, even pharmaceutical applications are also there. Let us say what are the different contents of colloidal dispersions we have to discuss. The contents of colloidal dispersions is number one, contents, that is introduction, classification of colloidal dispersion. There are different types of classifications are there. Preparation of colloidal dispersions. Here also different methods are there. You have to study what are those different methods of preparation of colloidal dispersion. After that, the prepared colloidal dispersions are impure. The impurities are removed from the colloidal dispersion. That is called as purification of colloidal dispersions. After purification, you have to study the properties of colloids. After properties, next comes stabilization of colloidal dispersion. Finally, the applications of colloidal dispersion. These are all different headings. We have to study in present this one. Okay. Next, one by one we will discuss. As far as these colloidal dispersions are considered, these are, the colloids is a Greek word. It is originated from, it means glue-like substance. Glue-like substance means it is a gummy-like substance. And these colloidal systems are defined as polyphasic system. Polyphasic system. That means in this dispersion, there are two phases are there. One is dispersed phase, another one is dispersion medium. One is dispersed phase, another one is dispersion medium. And dispersed phase measures 10 to 100 angstrom and are few micrometer. The size range is 10 to 100 angstrom and few micrometers. And these colloids are settled or made settled by the centrifugation method. By the process of centrifugation, whatever the colloidal dispersions have, these particles are settled by the centrifugation process. That means always whatever the dispersed particles are there in dispersion media, all the dispersed particles are uniformly distributed. Uniformly distributed in dispersion medium. Then only we are going to get a stable colloids or colloidal dispersions. And that means we already told there are two types of phases are there. One is dispersed phase, another one is dispersion medium. That means the dispersed phase, the particle ranges, the diameter between the approximately 1 nanometer to maximum 100 nanometer size range will be there. These particles are normally invisible, even they are optical, but these particles are observed under ultra microscope or electron microscope. These whatever the particles are dispersed because of small range. We can observe under ultra microscope or an electron microscope is used for observation of these colloidal particles. One more important is these colloidal dispersions are these particles are passed through the filter paper, ordinary filter paper they can pass, but they cannot pass through the semi-permeable membrane or diffusion membrane, you can say semi-permeable membrane, that is also called as SPM. But these colloidal particles can diffuse through semi-permeable membrane. And here we are going to discuss or differentiate different, because I already told the dispersal phase and dispersion medium. Like that, different formulations are there. Number one, solutions, colloidal mixtures and suspensions. All the three we have both phases, dispersal phase and dispersion medium. Then what is the difference? This is important. Of course, whatever the preparation or formulation we are having two phases, it is not a colloid, it is not a solution, or it is not a suspension. There is a slight difference between these. What is the solutions? That means the solutions are nothing but these are the made with particles are solutes and solvent. In this case, the solvent usually liquid, but can be sometimes we can use it as a gas is also used. But these particles are atoms or ions or whatever you say molecules that are very small in diameter when compared to colloidal. In the diagrammatically we have seen this is the true solution. You see the particle size, you see the true solution as well as colloidal dispersion as well as suspension. In case of colloidal mixture, the particles are having small than when compared to solutions. They are large size when compared to these true solutions, but smaller than suspension. Smaller than suspension. But whereas normal suspensions, what we have already studied in B.Pharm first year, these particles have dispersed in dispersion medium, but the size range is larger than colloidal mixture. Here you differentiate the diagrammatically. This is the diagram of true solution. The particle size is less than 10 to the power of minus 7 centimeter. Whereas colloidal dispersion, the particle size between the 10 to the power of minus 7 centimeter and 10 to the power of minus 5 centimeter. But in case of suspension, the particle size range is greater than 10 to the power of minus 5 centimeter. You see, you observe. This is the particle size range, what we have seen, observe. These are the very small. And here when you come to colloids, the size of the particle is somewhat big. And whereas in suspension, the particle size range is. In this way, we can differentiate, of course, all the three things. Two phases are there, but the differentiation is depending upon the particle size range. We have differentiated these three, that is true solutions, colloidal mixtures and suspensions. And here comparison, a property of solutions, colloids and suspension. Here I already told this is the solution. For example, you take a salt. That salt is dissolved in water to form a uniform solution. That is, the salt is freely soluble in water. We are going to get a whatever the solution that is true solution, that is called as example of solution. Coming to suspension, you take a flour, any wheat flour or any flour that is suspended in a water with blue cast from the light scattering of that flour particles. That is called as suspension. We're coming to our colloidal dispersion or colloids, you can say. The milk contains butter fat globules are dispersed in a watery liquid. that milk contains, of course, the butterfly globules, that is called as colloids. This is the example of our differentiation. Previous slide, what we have seen, the particle size differentiation between the solution, colloids and suspension. But here giving examples. This is the differentiation between the solution, suspension and colloids. But here in the particle size range, you see this is the solution is very smallest particles.